DHCP stands for Dynamic Host Configuration Protocol, and it operates at layer 7, that is application layer of OSI model. It is used to assign IP addresses to the endpoints over a network, and these IP addresses operates at network layer, that is layer 3 of OSI model. Now this is a network switch, and to one of its port this authorized DHCP server is connected, and to another port this client is connected who wants to get an IP address automatically from this DHCP server. So client will send the first DHCP Discover message, and this DHCP server will send the second DHCP Offer message, and the client will send the third DHCP Request message, and the DHCP server will send the final fourth DHCP Acknowledgement message. So client will get an IP address from the DHCP pool of this DHCP server, and other network configurations, for example, DNS server or the gateway IP address. So the client will communicate over the network by using these network configurations. But here is a vulnerability in this process. So a hacker can set up a rogue DHCP server and can offer the rogue DHCP configurations to the client in response to client DHCP Discover message. So these rogue configurations may include the IP address of the fake gateway. So client will send all its traffic to this fake gateway, that is the hacker machine, and hacker can perform man in the middle attack by sniffing all the traffic from the client and then forwarding this traffic to the actual gateway. And other security issues that the hacker can connect to a switch port and can send multiple DHCP request message to the DHCP server by changing the MAC address in each of these requests. So in this case, the DHCP server will deplete all the IP addresses in its DHCP pool. So this is called DHCP starvation attack. So in this case, any future legitimate client will not be able to get the IP address from the DHCP server, since all the IP addresses will be depleted by the hacker. So the any future client cannot be able to connect or communicate over the network. So in order to prevent such attacks, there's a security feature which is introduced in the switches, that is DHCP Snooping. So once this security feature is enabled on the switch, then all the ports on the switch are registered as trusted or untrusted for our DHCP server to connect and offer DHCP settings to the client. So in this case, the hacker cannot act as a rogue DHCP server or cannot send the DHCP offer message on an untrusted port, and such messages will be blocked by and dropped by the switch. Furthermore, uh, after the fourth DHCP acknowledgement packet by the authorized DHCP server, a registry is made in DHCP Snooping binding table on the switch. So in this binding table, the port and the MAC address of the client along with its IP address is registered. So hacker cannot send multiple DHCP request message by changing the MAC address in each of these messages because single port will be registered against a single MAC address. So a hacker cannot perform the DHCP starvation attack against our DHCP server. So this was all from site. Thank you.